this has actually come in, and I'm going to do this before it's due. I've got an Amstrad 901 from a radio ham friend in where he's sorted out the transmit problems, but he's struggling with the receive. But it's a nice day today, and if we can fix this DNT 4000 CEPT only set, we'd be able to do a field test with it, or with ours. This is ours. This scruffy one with no battery door is ours, but it did come with an intact aerial, which is why I bought it some years ago. And this beautifully packed one is the customer's. Don't know there's a letter in there. I'm not going through the mouse's nest to look either. Gentleman's a regular. He's not only a trade user, but he's got quite a collection of sets himself, personally. So put ours on one side. We'd do the field test with ours, because these aerials are potentially fragile, are they not? Yes, they are, Mr. Tango. So his serial number is 30682, and ours is 276. So his is newer than ours. So this is the DNT Hi-Tech 4000, which is CPT only set, and I would presume is very similar to the Eurosonic EU40, but a CPT version. I've never seen inside one of these. I bought ours a good 10 years ago. Glad I did, because prices have shot up, haven't they? So let's have a look inside this customer's one. Yes, it's got some dirt on the battery contacts, which we'll look into. At least it's got the screw, which is often missing. And can I get it out? No. And because we're doing that Eurosonic set, we've still got some of the special jigs kicking around, like the aerial adapter. There we go. We've got a call tone on this, which theoretically on 2781 wasn't really permitted. Can I get into it? No. No, it's much higher quality than the Sonic. So clearly the interference specification for CPT, well, we know it's higher than 2781. So you've got a lot of shielding which you wouldn't have got, and that's going to make for a better set. Wow, that's not what I was expecting. Looks like it's been damp at some time. So we'll set our power supply to 12 volts. Now, on the Sonic, the Eurosonic, it was negative center. Oh, now that's a dilemma. This is positive center on a 2.5mm socket. So we're back like the DNT. No, this is the DNT. We're a bit back like the Harvard 410. Does this power the radio, or is this just a charge socket? So I'm going to have to see if we can dig out our 2.5mm adapter lead, which we no doubt made up. I think for now we'll power it from the... Oh, you can't really get to those, can you, either? That's interesting, they've used a screened lead to the battery. Is that so you don't get feedback in through the rod antenna? Quite possibly. So, does it have an antenna socket? No, it doesn't, does it? Oh dear. So it hasn't got anything like the socketry that we've come to expect. Appears to have got an antenna relay there. So this is a pain in the what's it to work on, because we can't get to the. Oh, what they've done, they've put, look, there's a test point there, so that's the far side of the loading coil. So that's your test point, then the loading coil, then the rod antenna. So yeah, could be the crocodile clip lead. So I'll see if I can find our 2.5mm adapter lead, otherwise we'll use the crocodile clip lead to the battery terminals. So I was going to say to you, well, we haven't got a circuit. I've just done an internet search and I found a circuit. I didn't find anything else. So we'll see. It shows the microphone, preamplifier and speech processing on a separate board, so that'll be interesting. So Mr. Chippie's just made us up a 2.5mm lead. So we'll plug that into there and we will connect it to our power surprise. It's like a power supply. And it's positive inner. So hopefully we are now powered up. So doesn't power the set from there. So it may just be a charge socket. Well, you could look at the circuit diagram, it would soon tell me, wouldn't it? So that's our positive, that's going to be our negative, and as you can see, you also see the dirty contacts. We've got power there. So look at the circuit diagram. Battery, charge jack. So I'm presuming that the switches, you've actually got a resistor and a diode in there. So I'm presuming the switches is inside the jack is arranged in such a way that the radio doesn't function when the charger is plugged in. So it's not like the Harvard, etc. So that's tested that. Thanks, Mr. Chippie. I'll put that on one side for next time we lose it. So it looks like we do power it from the battery terminals, which I never like doing. So that's going to be the positive end. That's the negative end. Does the radio power up? It does. So there is no external power socket. Display on and off, but it's on channel 9, so that may be inhibiting the display. It is. So when it's on channel 9, the display goes out, just like when the display is off. Good. It's going to be a right bundle of crocodile clips, this job. So I've got I'll move that out of the way. I've got the radio connected to the test set. I'll switch picture in picture on and I'll press transmit. And it's not moving the needle, but it is transmitting. So that's low power. Nothing. High power. Nothing. So I'm not sure where all the power's going because it's doing something. Well, we'll see whether we can receive on it if it's not wanting to transmit. So we're going to have to change our thing big time because we're not normally on CPT channels. The 27205. There we go. Let's put some signal on it. So that's S9. If I didn't know better, I'd think the relay was not working because we've got very poor receive and we've got an attempt to transmit, but nothing actually coming out. Aha! Dirty connection. On high power, we have got, it's soon dropping off, aha, it's suddenly gone right. 27205, and we have got just over 2 watts. You know what, I think our BNC's dodgy. Yeah, it's our BNC that's dodgy. Okay. And on low power, it's doing 300 milliwatts. Need to retune the mod meter. I'll tell you what, we've got call turn on this. Wallow. It's a bit low at 1.5. So that's going to be on the lower board. So, like with all these, we seem to have to take the board out to do anything. sure why the lid's come off that. Bits of plastic coming out of the set as I take them on. There we are. Just as it says in the circuit, there is the speech processor board. And our deviation control is apparently on there. I can't see it. No, it's not. The deviation isn't on there. I'm telling you fibs. It's RV5. So we need to get down to there to get to the back of the speaker to do the synod meter. So RV, can't read it, there. RV3 is Squelch, because I spotted that in the circuit diagram. If that's RV1, that is actually the S meter adjustment, believe it or not. Ah yes, that'll be deviation down there. So we'll use the call tone. Not quite sure why it isn't permanent. No, we'll use our oscillator. No, it doesn't look like that's affecting it. Not that one then, is it? That's RV3. So RV1 is RX meter. That must be our RV2's Squelch then. Low power. Switch to low power. I'll turn that oscillator off, we're not getting anywhere. So low power. Is it that one? No. Is it that one? No. Is it that one? Yeah. We'll set that to 400 milliwatts, just like it would be on 2781. So that brings us to where's deviation. We know it's RV5. We know that's 3, we know that's 1. So it only leaves us with that one. And it is that one. It's not very effective though. Wallow. 1, 2. Okay, well, that's about where it is. Not ideal. I think we need to go through the transmitter, so we'll. So, transmitter strip. So we'll bang on 2 watts there. How many watts are these anyway? I mean, we're guessing they're 4, but it doesn't say anywhere on it, does it? Yeah, that's it. So 2.6 watts. So what does the meter say? Yeah, it goes across. Very nice. So is it on frequency is our next question. So we'll look at 27205. Hang on a minute. Are we not on channel 20 anymore? No, we're on channel 9. And now the power leads are dropped off the battery. And that's corrosion. So we'll now power it. We'll just cut that very end off. So 2720480. So hopefully there will be a crystal trimmer, and there is just there. There we go, 27205. Yep, 2.7 watts. So we'll now look at the cyanide. So for that we're going to have to hold the wire on. I'll switch the camera over to the cyanide meter. Take the rail out of its case. There we go. At the moment, this radio is doing 2.8 microvolts for 12 decibel cyanide, which isn't that good. Recheck, it's just got better. 2.3. Okay. So we'll go down, see whether we can improve the radio. Same pretty simple receiver as you got on the Harvards, etc. Recheck the others. I've got another one there. Just see if that's a detector. It could be. In case it is, we'll go over to the oscilloscope. It is. So it uses a better technique than the previous ones. So now we'll go back to the cyanide meter and we'll see what it's doing. Yeah, it's 2 microvolts for 12 decibel cyanide. It's not brilliant at all. But what can we actually hear it down to? That's 0.3. Hear it down to nearly 0.1. It's just that with the cyanide, it's working out with the noise, and it's a bit noisy. So that's the best we can do. It's crystal filtered, which is by the looks of that, which yeah, it looks like 10.69. I think it is. Turn the radio over. Yeah, it is. So, where does that leave us? We need to set the S meter. And that's RV2. No, it's not, it's RV1. And RV1 is that one. So somehow I've got to turn this round. And that's set to 9. So that's that done. Let's look at Squelch. So turn the Squelch to full. I've got no Squelch action at all. So it's definitely RV1. Oh dear. So although it distinctly says that RV1 is Squelch, RV1 isn't Squelch, and the one we thought was perhaps deviation isn't. So here's Squelch. Wanted to open it at 100 microvolts, and that's it now does. So at the sensitive end, let's test that. About 3 microvolts. So that's working. So is that the deviation? Let's have another look. Wallow. Wallow. 1, 2, 1, 2. That looks to be where we want to be with the deviation. So deviation. Wallow. 1, 2, 1, 2, 1, 2. Wallow. 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 So to be clear, deviation, S meter, Squelch. Right, I'll put the radio board back into the case. Okay, so we've put it back together. We're as done as we're going to be done. So it's disappointing because it doesn't have an extension aerial socket. So we won't be able to do an on-the-air test. We'll only be able to do a field test. And I might look at mine. Now, this has clearly been very damp at some point. And we are going to address these battery connections, which have got some corrosion. Take that off now, we're done. So I'm powering it up from the crocodile clip leads on the bench at 12 volts. We know it's doing 2.7 watts, not brilliant sensitivity, 2.3 microvolts, but all that said, it was receiving. I mean, the S meter is reading S7 with nothing. That's really good, isn't it? That's just picking up the signal generator by proximity. Yeah. I've no reason to check the loading coil. It's still in its waxed position. So we'll just go through channel 9, charger only. High power's 2.7 watts, low power's 400 milliwatts. And that's actually grinning. This has been dropped numerous times because there's bits of plastic have come out of it, and that could be why it's grinning just there. Yeah, it's not wanting to go in, is it? You've got a call tone which is reasonable, and then you've got a display on and off to save battery power. So although it meets the interference standards, it's not an improvement on the Harvard 410 because it's I have to look at that because you've lost your extension aerial socket, which was on the top of those, so you can't power it from an external power source, and you can't run it into an external aerial, so it's just a walkie-talkie. So we'll do a field test with it. I'll just look at that. I just thought I'd put my one on, and which looks a bit scruffy, but inside mine's pretty pristine and there's no ingress of moisture. One of the problems with the customer's one is I can't pull all the aerial out, and I daren't. I might put a lubricant down. I wonder if it's kind of corroded. It's the bottom, next to the bottom section. So I've just set the deviation on this, just set the low power, just got the power. Let's go into, if I can find my remote. So if we press transmit on my one, that's low power, and that's high power, which is 2.9 watts. So 2.7 on the customer's 2.9, and it's interesting that, I mean, I've no idea what these are rated at, but we can tell with two of them that it's somewhere around the 3 watt range. And on receive, I've not been through my receive yet, but it's lousier than the customers, and the customers isn't very good. So we'll whip my board out and I'll just check that, and I'll come back to you with the figure. So I've tuned mine up now and I've got similar results. So there's, well, near enough 12 decibels. And if we look at the attenuator where I've got that set, you can see we're on the 3 scale and we're dead on the 3. So his was 2.5 microvolts for 12 decibels, mine's approaching 3. So mine's doing a little bit more power on transmit and his is doing a bit better on receive. So I wouldn't put one of these on your wanted list, but of course if you collect CB radios, you need one in your collection. So I think that's my one about done. Yeah, I've brought that up quite well. I'll just check my Squelch. It's 30 microvolts, I won't bother adjusting that. We'll just look at my S meter. It's a bit generous, to be honest. Take that down a fraction. There we go. Mine was well off frequency, it really was, but it's spot on now. So if we can get his antenna out, we'll do the field test with his set. Otherwise we'll do the field test with my set. So the difference here, now we've got it off the aerial or the connection to the test set. If I turn up the signal generator and it just picks it up through proximity, I've not got this S meter problem with it hanging on in there. I'm just going to press quickly transmit. I better pull the aerial up, hadn't I? So my transmit light's working and his isn't. I might look at that. I'm not sure how much I dare take apart because it's the delicacy of his set with it having had moisture in it. So ours is spot on. I'm really saddened that we can't test this on the aerial. You know, it makes it quite crummy, to be frank. So go back to his. I'll pull up as much aerial as we've got and put it in low power so we don't ruin the transmitter. Can you see? There's another section in there. Well, I'll put some WD-40 down there, see whether we can release that, and I'll see whether we can change that LED. Having opened the customer set back up to do the LED, and it was a Duff LED, I've just replaced that. When you start looking at the underside of the board, and I'll just zoom in on that, you can see that there is the ingress of moisture. Just down here. So what we'll try and do is get Mr. Chippie's toothbrush to it. So how come the LEDs failed on transmit? It's not like you're in transmit for 20,000 hours. That's the worst bit. So that's as far as we're going to get with this. Let's put it on. I've stepped the S meter reading back. Hang on, we're in the wrong. There we go. So we've got less residual background noise. When I put the signal generator on, which is just not coupled, we can see the difference there. Just quickly transmitting low power with the aerial not fully out, and we've got the TX light now, and that brings us to the aerial. So that bottom section, I've put some WD-40 down there in the hope it's going to free it off, but I can't get that out. Now I don't want to pull it and ruin it, so I'll let the customer do what he does with his whatever he uses to unblock things like that. So it looks like we're going to be field testing our one of these. So this is doing 2.7 watts, ours is doing 2.9 watts. They're still both, this is doing 2.3 microvolts for 12 decibel cyanide on receiver, and ours is doing a little bit worse, 2.5. So they're hardly the last word in the way these work, and the disappointment with no external power connector, and it's bad enough when you haven't got an earphone socket, you know, and we have to start stripping the radio down to get to the loudspeaker. But to not have an external power socket and not have an external aerial socket, you really are, you know, not good at all. So there you are. That's the DNT 4000FM, which will be from 1987, and it's a PR27 format set. So it's CEPT 40 channel only FM, and I say it's this one's 2.7 watts. So I think they're probably supposed to be 3. So that's it, and the next one of these you'll see will be an on the air test, but using our scruffy one. Thanks for watching.